Hello students, today we'll start chapter 11. Let's start with section 1, Set Language. A set is a collection of distinct objects. Imagine in daily life, we have a bed, and there are 4 items inside this bed: pencil, calculator, highlighters, and eraser. So, how to use the set language to express this? First, you can imagine this bed is a set. So let's use a notation. For example, we use B to represent this bed. So we call this set B. And these 4 items inside this bed, we call it elements. So this means we have 4 elements in this set B. So if we want to write it in a mathematical language, we can write B. This set equals you just simply write the elements inside this set. So eraser, and then you get pencil. Just a reminder for you, the order is not important when you write your element in the set. Pencil, and then the next maybe the calculator, and then lastly we get the highlighters. So this is a very brief example of a set, and we'll go through more in the coming part. Now imagine we get a set A, and there are some elements which are numbers inside this set. So as the example we showed before, we can write A equals to a collection of these 5 elements. And also actually we can write A equals to X, and we try to describe what is X. So here we can describe X is for example a positive odd number, less than 10. So we can also write in this way, they are equivalent. And we can also write something like NA. NA stands for the number of elements in A. So how many there? 5, right? So we get NA is 5. Now let's go to the right hand side. Here we get these 4 symbols. The first one is an element belongs to a set. So for example, now if you see 1, this number is inside the set A, right? So we can write 1 is inside A. And now, you see in the set, we have no 4 there, right? So 4 is not belongs to A. So this is the second symbol. For the third and the fourth symbol, they are actually comparing or considering 2 sets instead of elements. So, for example, if we consider another set called B, and B we get 1, 3, 5. Then you see all the numbers 1, 3, 5 are also in A, right? So you can imagine B is actually inside the A. So we say in this situation, B will be a subset of A, which is the third symbol. A subset here. And we get another one. If we get another set which is C equals to 1, 3, 6. So, okay, although you get 1, 3 inside the A, but actually the 6 is not inside A, right? So C is not totally inside the A, okay, in this situation. Then we'll write C is not a subset of A. Okay, get it? Now let's go to the other part. Here we'll look at what is two special sets, which are universal set and empty set, and sometimes we call it null set. Let's go through the wordings in blue color. Universal set is a set that contains all the elements under consideration in a certain context and denoted by U. It stands for universal. And for empty set, it's a set that contains, okay, it's a big contrast, which is no elements under the certain context, and which is what we call this is empty set or null set. Okay, there are two names here. Okay, empty set or null set. They're the same. So let's use an example to illustrate. Consider the outcome of throwing a die with 6 faces. So what are the possible outcomes? You will get 1 or 2 or 3 or 4 or 5 or 6, right? So the universal set in these situations or in this context will contain, okay, all these 6 numbers. Okay, and now if we consider another set A, which is x and x will be greater than 6. Okay, under this context means we throw a die and we look at the outcomes. Will A contain any elements? That means will there be any outcomes which is greater than 6? Obvious, the answer is no, right? So because there's no elements, okay, right, in A, so we will like, okay, A to be an empty set in this context. Okay, get it? So let's just quickly give you another example. For example, if you flip a coin, then you will get head or tail, right? So the universal set, it will be a set containing the head and tail, these 2 elements. Okay, and for the empty set, maybe you just get something like totally irrelevant, like if you get 1, okay, or then sure if you flip a coin, you will only get head or tail, but not a number 1, right? So if you get a 1, then this is a empty set, okay, in this context. Okay, let's go to the next part. Okay, Venn diagram. Okay, a Venn diagram is try to represent a set or some of the relations between the sets in a diagram. So in this Venn diagram, we use a rectangle to represent the universal set, and some circle or ellipse to represent the set inside this context. So on the left hand side, we would like to look at the graph and try to write down the set. Okay, so A, if we look at A, what will be the elements inside? So A, let write it, okay, draw it here. Okay. Then A is this one. So inside this A, we get 1, 2, 3, and 6, right? Then what is inside the B? Okay, inside the B, we get 3, 4, 5, right? Then what is inside the C? So we see C actually is a subset of A, okay, because it is totally inside A. So the C, you will get 1, 2 only. And you will also find these 2 elements in A, right? And finally, we can write down the universal set. So we cut all the elements inside this rectangle, and then we will get 1, 2, 3, 4, 5, 6, 7, and 8. Then you may notice that the 7 and 8 actually are not belongs to any of ABC, but okay, it is also under the context, okay, inside this element of the universal set. So now on the right hand side, we try to look at the sets and then we construct the Venn diagram. So let's try to draw a rectangle first. Okay, and then we write this as U. And we try to draw a circle. And if this is A, and then we can write 1, 2, 3, 4 inside, right? But before we draw it, we also look at 2, 4, also in B, right? So we can write it here, and the 1, 3 here. Okay, and then when we try to construct the B, we can also include A, 2 and 4. Right? And then you get this 6 is in B but not in A, so we write here. And then when we look at the universal set, we still have 5 missing, right? So we write it outside A and B. Then we find it, okay, the Venn diagram of these 3 sets. Okay, so let's go to really the last part of this session. Okay, we talk about unions, intersections, and complements of sets. Okay, now we have 4 sets. Okay, universal set 1, 2, 3, 4, 5, 6. A 1, 2, 4. B 1, 3, 5. C is 5. Okay, if we want to consider the unions of A and B, then actually we are considering the elements belongs to A or B. So you try to look at the elements, okay, in A or in B. Okay, then you can just write that. So here we get the notations. A union is just like a U, okay, union of B, and this is okay. Someone okay, you can interpret as A or B. Okay. Then first we can just look at A 1, 2, 4. So it is in A already, so we can just write down 1, 2, 4. And then we also write down those, okay, in B. We get 1, 3, 5, right? So because 1 is already here, so we don't need to copy it. Okay, we don't need to repeat the number. So we write 3, 5. Okay? Then actually you can write 1, 2, 4, 3, 5. Or sure, you can also arrange it to 1, 2, 3, 4, 5. Okay? The order doesn't matter. Okay, and then now let's go to the intersections. Okay, intersections means again all the elements that belong to both A and B this time, but not A or B. So A and B, or A intersect B, we just opposite the notation to union. Okay, so we get this. You will easily mix up these two, okay? So trust me, okay? You can just try to remember union like a U, and then intersection is the opposite of U, okay? So A, and sometimes you can just interpret this as A and B. And then we try to look at the numbers which are in A and also in B. So I think you can find which is 1, right? So the intersection of A and B only contains 1 element, which is 1, okay? And if we consider another one, A intersect C, what will happen? You see 1, 2, 4 in A, right? And then you 5 in C. There are no common elements, right? So A intersect C will be an empty set. And in this situation, we call A and C are disjoint sets. It means there are no intersections between them. Okay, so now we go to the last part, the complements of A. Actually, complements of A is a set contains all the elements not in A. So you may just imagine it is not A. So we will denote it by A prime. Okay, you just get these notations. So let's use the example again. Now we get U is 1, 2, 3, 4, 5, 6, and A is 1, 2, 4. So if A is 1, 2, 4, then what is not A? Not A means the numbers in U but not in A. So remember, it must be in U. It must be under our context, okay, our consideration in the context. So it should be 3, 5, and 6. Okay? Then here we come to two important notes of complement. For any sets X, the following must be true or must hold. Okay? The first one, X union not X must be equal to the universal set. Like, okay, these examples, if you union these two, you will get 1, 2, 3, 4, 5, 6, which is U, right? And the second one is about the intersection. Can you imagine what will be this? X intersect not X. Yes, it should be equals to null set because, like the previous example, A 1, 2, 4, not A 3, 5, 6. Then there's no common elements, right? So you will get this is equals to null set. Okay, so these two must hold for about the complements of a set. And this is the end of session 11.1. Okay, so see you tomorrow.